Hello, everyone. My name is Dimitar, and I'm the founder and CEO of TechTalks, which is a network consulting and software development company based in Bulgaria. And with us is Dmitri.
Hello, everyone. My name is Dmitri. I'm network architect in a global company responsible for network and data center. I'm VCDX 279 in network virtualization. Dmitri, to you.
Yes. So a couple of words about our team. We're focused on networking and security, as well as software development, and the combination of both things led to the creation of our software, AutoNSX, that we will be presenting you today. So what is AutoNSX and what problems does it solve? It is a network and security policy management software that integrates vRNI and NSX. It helps organizations to address the challenges of building and maintaining their security frameworks by simplifying and automating their day-to-day operations. As you all know, security frameworks are complex by their nature and require detailed technical knowledge and knowledge around the applications running in the data center, as well as knowledge about their relations. Once a security framework is applied, it is just the starting point. Going forward, it requires regular maintenance and updates of all objects in order to ensure compliance. Manual implementation increases chances of human errors, and so, as most of the work is done manually or in semi-automated scripts in semi-automated way with scripts, this increases the chances of human error, as well as taking a lot of time for the actual implementation. And long implementation times mean outdated security policies, which of course lead to security problems. Once the framework is applied, it needs to be modified every day and continuously in order to ensure that the applications are running smoothly. So the security today is really very dynamic. And last but not least, governance is a crucial demand for organizations. Scripts and direct updates do not provide the needed level of governance. People want to know what was changed, when was changed, and have some sort of history of all the changes related to the security of the data center. And when the work is done manually and with scripts, this is simply not happening, which is a big problem. So how we integrate vRNI and NSX, what our software does. First, we collect the suggested rules from vRNI, as well as all the member VMs of the application that we are about to publish to NSX. Then, as a second step, we enrich these suggested rules, matching them to a predefined set of conditions and applying the necessary changes. This includes, for example, replacing ports with port ranges, replacing source and destination IPs with IP ranges, creating rules in different policies, and many others. One example I can give is when you have a VPN setup and vRNI captured one user connecting to the VPN, so we want to allow this, but this is just a single IP address that was captured by vRNI, so the rule will only include that. What AutoNSX will do is that you can define a criteria saying that if the IP address matches a criteria, then you should replace it with the whole subnet for the VPN. This way, the rule coming from vRNI will be only for a single IP address, but it will be automatically transformed for you by replacing this IP address with the relevant subnet, meaning that you will correctly publish your rule and the VPN will function correctly. Another possible thing to do is to replace a port with a port range when you have applications using many ports, and say vRNI captured a single port, and if this port actually falls in a certain range, you basically know that you need to replace the port in the rule to include the entire range. So this is also done automatically by the software without needing any user input. There are many different criteria that can cover most of the usual day-to-day necessities. So this really lowers the amount of manual work that needs to be done. After the suggested rules obtained from vRNI are enriched, then the next step is to allow the addition of some additional default rules. They can go either before or after the suggested rules, and their purpose is if you need some particular rules that should go at the beginning or at the end of each policy you're publishing, this is why you define them. After the rules must be, these are rules that must be present in all policies. For example, rules allowing ports 80 and 443 may go on the top of the policy. You can have deny any rule at the bottom of the policy. It just depends on the network security design and how you're handling things in your organization. So you can cover this as well. And then after everything is ready and the set of rules has been enriched and also additional rules have been added, you now have the complete set of rules that you want to publish to NSX. At that point, all the necessary objects will be created. This includes security. This includes groups, IP sets, and the policy and all the rules. All of these will be automatically created based on the list obtained that was populated. After that, you can run this workflow multiple times, updating the policy that was published, meaning that if your application is using different additional ports or something needs to be opened and vRNI has captured some new flows, you can run the workflow again for the same application. It will detect what rules already exist and will only add the new rules to the policy. So with that being said, let's continue with the actual demo so you can see the software in action. Okay. So the first time when you open the software, you're presented with the list of the applications that you have already published. And inside this list, you can quickly see the current rules of the policy that was published for this application. And you can also see a history of what was published and when and by who, as well as seeing the actual objects that were created during this publish process. There were security groups created, the section, some tags were assigned, IP sets were updated, etc. This is the governance that we discussed, and this allows you to quickly and easily see when was the application published and what changes were made. As part of the setup of the software, you define the source, your data sources. The data sources are the vRNI and NSX instances that we are connecting to. So the vRNI instances are considered the source of our workflow, and the NSX instances are the destination of the workflow. So you define your vRNI instance as a data source and your NSX instance as a data source as well. After you're ready with that, you can start the workflow, enter a description, then choose the vRNI instance, choose the NSX instance you want to publish to. You can also choose what default rules and conditions to apply. Then we proceed on the next step. In here, you can define a security zone, which can be application or production. And choose the application you want to publish. Click Next. At this point, the rules are obtained from vRNI, and then on the next step, the user is presented with the list of the rules. And these are the rules that are going to be published. One more click, and then publish. And this is all that is necessary for you to microsegment an entire application and have it ready and set up in the data center. Thank you very much for your time.